In our final topic of Chapter 3, we're going to look at a very closely related method to the Newton-Raphson algorithm. And I must say, it isn't quite as powerful. However, it does have the advantage that if your data comes from a table rather than from an actual functional form, it's something that you can use. So let's take a look at the secant method as a way to replace the first derivative if you can't get it. So what would we do if we didn't have that derivative? Well, we could always go back to the definition of a derivative and take the function evaluated at x plus h minus the function evaluated at x and divide by h and take the limit as that function goes to 0. Well, you can't really take the limit all the way, but you could allow 2 points to be spaced closely enough together that h would become the difference between two adjacent points. So let's try that. We're going to estimate now the derivative as being a rise over the run in a macro sense. So we have two close values, and we will take the rise over the run and call that our slope. If we did that, we should be able to substitute this value into that formula. And that would be just taking the reciprocal of our slope and multiplying it by f sub x sub n. It's just a matter of taking that formula and replacing it with the Newton-Raphson formula using the exact same code that we had before, and you're good to go. There's some other topics in your text that are of use. One is a more detailed description of convergence. We're going to skip that for the secant method. It is a little bit complicated. We'll save that for graduate course as well. And there also is a discussion on hybrid schemes where you can combine different methods together. Again, we're going to skip over that in favor of other applications. So here we have now homework 3.3. What I want you to do is create your own pseudocode using the Newton-Raphson as a base and convert it to the secant method in the way we just described, and then do problems 2 and 3, and if you'd like extra credit, do problem 10 as well. And that concludes Chapter 3. We're going to move to Chapter 4 next time, where we start looking at interpolation and, more importantly, differentiation. See you then.